Hello and welcome to this breakout session with Innova Systems on Customer Day 2014. My name is Matthew Goldwater and I'll be running through with you sheet metal and weldments. The case study I have for you is just a simple playground slide. We're first going to create the 3D sketch and 2D sketch for the weldment frame, followed up by a custom weldment profile that's configurable. Then we're going to create a swept flange for the slide itself, followed with some simple sheet metal features. So let's go into 2015 and start the weldment frame. So to create our weldment frame, let's do it as a 3D sketch. Now you can start straight from the weldment tab and open a 3D sketch right here. Or you can go into sketch, expand the sketch icon and go 3D sketch. Now it doesn't mean we can't sketch on the planes or existing faces. To do so, we need to double click on, say, the right plane, which will make it active, like we can see here with the grids. This means that whenever I place a sketch entity like the midpoint, from the origin out horizontally, it'll be placed on the right plane. Now to come out of the right plane, we expand our sketch tool and select 3D sketch on plane. And we can carry on sketching if we please. So we'll select our line tool and we'll go from this endpoint out. Now you can see yellow lines indicating the orientation in which this line is going to be placed on. It can either be an X, Y or Z, or anywhere in between. Now I've got it set to X and Y. You can see at the end of my mouse there. So if I place this on this axis right here, we can see in yellow it's indicating that it's going to be on the X axis. Now I want to come down and create the Z axis. Now we don't have a yellow line indicating that it's going to be placed on there. So we need to alternate. Selecting the tab key on our keyboard, we can alternate between the axes. And we can place it on the Z now, followed by the X to finish up and close the sketch. Now I want to create the legs of our model, and this is going to be down the Y axis. So like so. Grab that and we'll coincide it to our existing sketch. Now what I'm doing is I just did a Control C and then a Control V of that sketch line. Just saving a bit of time so I can just go around and add these coincident relationships. Now I want the tops of these legs to be all even on the same plane. So what we could do is we could grab a center line, go from there to there. Same again. And this time we're going to select these lines and run them through the x-axis. You can see them snap into place like so. Now they're at different heights at the moment. So what we need to do is we need to place maybe these points along the z-axis. And now they're even. Now I want a bar that runs across the top here. So I'll grab my tangent arc and I'll run that around like so. I'm also going to go ahead and I'm going to create a ladder for this frame here. So I'll place the ladder approximately where I want them to be. Now what you can see with the ladder though is that I can move it side to side. That is indicating that it's not properly fixed in place. So to do so we can select the line, go to our feature tree and select, say, the front plane and add a parallel relationship. Same again, front plane, parallel. We can also finish this off with, say, a relationship down the z-axis, followed by some more tangential arcs. Okay. We'll just make these arcs equal to one another. Now I want these arcs to be following, so they're tangent to the ground. So I'm going to grab my center line down the y-axis, that sort of size there. Now we need to add a relationship between these construction line and arcs, so we can select the point now in 2015. And I'll add the relationship between the two entities. So nearly done. We're going to grab our sketch line and we're going to go along the z-axis from midpoint of our stringer to the other stringer. Two more down the bottom here. So now we need to actually place them evenly through one another. So we could actually grab a construction line and go from the midpoint down to midpoint of each of the rungs in the ladder. I won't do the bottom one because it's fixed at the bottom there. So we'll select these construction lines and we'll make them equal. Lastly, we'll grab some more construction lines and we'll go from this point out along the x-axis, so tab, to about there. We want to do the same on this one down here. We want this point on that side to be merged, and the same again on this one, merged. All we need to do now is actually merge these endpoints to the construction line, like so. Lastly, we'll add a relationship for these two to be following the z-axis. Okay. Now we can go ahead and dimension this as we please. So we'll add a degree of, not that one, between here and here, 30 degrees. Now we want a width, say, of 700. And we can also go from diagonal to diagonal. Now it's going to be that sort of dimension, but we could select our tab key to alternate to 1000. We could put a radius of, say, 500. And then a height, same again, diagonal to diagonal, tab, tab. We can do a Y of 2000. And we'll have an overall height of this, say, at 200 mil. Alright, so our sketch is fully defined. I'm happy with that, our 3D sketch. So let's exit that and move into creating our 2D sketch. So the 2D sketch, I need to sketch on a plane, obviously. So the front plane is probably the one I want to create the bar running down for our slide, but it's currently running through the middle of my model. It's not exactly where I want it to be, so let's create a plane on these points. We'll open a sketch on that plane and we'll use existing geometry from our 3D sketch to convert and create various other sketch entities. Going into another arc by going back to the end sketch point, tangential, into another arc, and then vertical. Wow, tangent for now. And we'll create that to be vertical and this one to be horizontal. In this point here, we need to add a tangent relationship. And we need a few legs just for support, somewhere in the middle there. We'll add a horizontal relationship between these points and our existing 3D sketch. Followed up with some dimensions. Say, let's make this back to our 3D sketch at 5 meters. And let's make it so this and this arc are equal, giving that a dimension of, say, 1000. A few more dimensions here just to wrap this up. And we've got a fully defined sketch that we can use to create our weldment. Now, to do weldment profiles, normally you'd use your your standard ISO or BSI or ANSI inch weldment profiles. But actually I want to create my own custom one. So I've gone ahead and I've created a sketch for my custom weldment. It's hollow in the middle and has a thickness of 5 mil. Now the difference between this is I have got two configurations. So I've actually got two sizes of the same weldment profile. This enables me to actually reduce my amount of sketching and enables me to just select the size of my weldment profile when I insert it into my model. So we can also insert some descriptions to the profiles. They will need to be applied to the configuration specific custom property list here. So I've just applied just the size of the actual weldment profiles. Alright, so let's save this as a weldment profile. Select the sketch, file save as. We'll change the file type to be library feature. And I like to place anything that I customize in my own location outside of SolidWorks. So on my D drive or your C drive or on your network, you have a folder maybe that has SolidWorks custom folder. And in here you have templates, BOM templates and alike. And we have weldments. Now unlike before, 2014, we had to have two folders, one standard and then another one here to say type, and then we'll place the weldment profile in that folder. But now we've skipped that type folder and we can place our weldment profile just in one level. So save that, and you can see it's turned into a library sketch. So I'll just go back to our weldment frame, and we're actually ready to insert our weldment profiles into this. Let's just make sure our system options or our SolidWorks is looking in the correct place for our weldment profiles. So we can see here at the very top, it's actually following my custom folder, Weldments, so everything's all good there. Jump into our Weldment tab and we'll select our structural member. And we can see our first option here, wow, our second one on this one is standard. That's the location of the generic ones. So we'll select standard and our type. Our type is that weldment profile we just saved, and then the size, which is selecting the configuration of that weldment profile. We'll go 50 by 50 and we'll start a new group. So I'm going to create the new group running around our sketched lines. Now each new group needs to be either in series or parallel to one another. Okay? And as I create the groups, you can see some of the sketching that is available. What you'll also see is that the groups actually automatically trim to one another depending on the order in which you select. So we can see group 3 that I've just selected here is automatically trimmed to group 1 and group 2. So that's done quite nicely for us. New group, let's do the ladder. Or actually let's jump down to this one here. These ones are in parallel with one another, so we can leave that in a group. And then we've got the ladder. Now if we have a look at the ladder profile, we can see it's just turned but skewed a little bit. So we need to align that. So we can grab into our alignment group box down here, and we can just select a line to align it to. Not only that, we can actually edit the profile or the location of the profile by selecting this locate profile. And we'll select one of the sketch points on our weldment profile to position it on the actual path, like so. And we'll finish that off by finishing off with the arc. Another group, same thing applies. We'll go alignment. We'll just align it to that vertical edge, and we'll locate the profile to be following that sketch point at the bottom here. Finish off that with the arc, and we'll move on to a new group for the rungs in the ladder. So again, we probably need to actually twist this so it's properly a little bit better. We could grab the alignment again and just drag it so it's on that line there, and we need to locate this point. But because this is all in series, we can go through and we can select the rest of the rungs. And you can see it automatically trims to the previous group that we did for the actual stringer of the ladder. So that's all we're actually going to do for this here. Give that a green tick, and we've created our first structural member. Now because we're going to select another structural member being another weldment profile, we should actually create a new structural member. So standard again, type, and we're going to do 50 by 100 this time in a new group. So we'll select our first entity. If I can select it, I'll just actually hide our 3D sketch. Don't need that anymore. And we're able to place our first member on the line. Now it's actually following the wrong alignment there. So instead of selecting alignment, we could actually rotate it 90 degrees. That looks pretty good. And it also always defaults to the origin of our weldment profile. So going through, selecting the rest of the entities, I'm pretty happy with that. We'll give that a green tick. Now there's one thing you'll notice though, is that between the two structure members, they don't automatically trim. So let's add some trim features to that. Now the body's to be trimmed. Let's work with this big main stringer body running down here. We want to trim that to either face or plane or bodies. To make it real simple, we'll select bodies and we'll select this member running around. Now in 2015, it's removed the callouts that tell you what it's going to remove, and now it's just telling us what it's going to keep. Just it's uncluttering our screen really. Give that a green tick. Now we have to create another trim extend down the bottom here for these two members. We have to treat them separately. So the bodies to be trimmed will be this one and this one. And the body we're going to trim to will be this stringer. You can see it automatically trims really nicely to wrap around. So we've got most of the frame here right now, looking pretty good. What we need to do is we actually need to mirror the bodies across to the other side. So having the front plane in the middle is actually helping us. We can actually go straight into features, mirror. We're not going to mirror the features, we're going to mirror the bodies. So select the bodies that we need to mirror, like so. And we've got a nice frame here, nice strong one, that's going to hold our slide. Some other things we can do, we could actually add end caps to the bottoms of our weldment frame. So end caps are easily done. We'll just do a group select over the faces on the bottom. Takes a little bit to think, but we can have a look to the left hand side and see what types of the end caps we can do. We can have the end caps on the outside of the faces or inside the faces, or we could specify where they're going to be manually. We'll have a thickness of our end caps going to be 5mm, same thickness of the actual pipe members. So you can see here this one's on the outside or on the inside, but we'll just leave it on the outside for argument's sake. We can also see that the end cap is covering 50% of the face, 0.5, of the bottom of our weldment profiles. Let's give that a green tick. We've got a number of end caps that have been produced. Alright, so let's give this a save whilst we're here. And we'll insert this into our assembly to create our swept flange for our slide. So to insert it into an assembly, okay that, and give that a green tick to align all the origins and planes. That one, sorry, frame. Alright, so we want to give this a save with the correct name, just so, because we're going to create our swept flange inside the assembly, so we want it following the correct name. So we'll give it a save, and I'll just place this on here, and we'll just call this playground slide, and save. Okay, insert new part, and we're going to select our front plane of this part to be the same front plane as the assembly. That opens a sketch on the front plane already for us. And what I'm going to actually do is I'm going to create a path for our sweep. And I'm going to follow the same path as the stringer of this member right here. So I want to make that a little bit visible. It's the 2D sketch, so I'll just make it visible. Select the sketch of the actual frame and convert the entities. Now we can see here down the end we've got a couple of entities that are probably just a bit too long, so we'll just trim these off as well. Don't need these. And now we're left with a nice path running down. I'll hide that sketch. So we can exit that. We've got our path. Maybe we could give it a name. Path. And we can carry on and we can create the profile for our swept flange. Now we need a plane to sketch on. Now the existing planes are not in the correct place. We've got the front there, top there, and the right there. So we need to create a plane. So select the endpoint and the line, go into features and plane. And that places it nicely at the end of my sketch line, which enables me to actually open a sketch on there. So I'm going to create a shape of our swept flange here. I'm going to use the existing geometry of the frame itself. So 5mm, we'll put that into, no, that's in the right orientation, give that a green tick. This one here, we'll do the same thing. Just give that an extension, and this one a bit of movement, and we'll do this side as well. Okay, we'll grab that like so. Now I want these two endpoints to be horizontal to one another, and I'm going to grab my tangential arc as well and just place it at the ends like so. Oops. Now we want this top of our slide to be running across the top of our members running down the slide here. So what we can do is we'll just drag this up a little bit, like so, and we'll select the actual edge of the member and we'll add a tangent relationship to keep it nice and flush. So it's just a matter of us giving this a bit of a trim, a bit of dimensioning as well. So we'll add a dimension of say 25 mil. Grab our trim tool, we'll just trim away this excess material here. Looks good. So lastly, we need to actually connect this to the path it's going to be following. So we'll grab a center line, we'll go up vertically, just make sure these ends are merged, and we'll pass this to the path. We should always do a pass relationship when we're doing a sweep. Now because this is a construction line, I can select all the sketch entities and just mirror them across the other side, giving us our profile. Okay. So now we have all the sketches we need to create our slide. We can go into Insert, Sheet Metal, Swept Flange. It asks us for the profile and then the path. And it produces a really nice sheet metal swept member there. So we'll grab a thickness of say 5 mil. We can see the thickness is going inside. We want to reverse that, and we'll have an internal radius. We'll leave it at 25. That sounds good. Green tick that. Okay, we've got a really nice bit of slide there that's really quick and easy. Some other things we need to do just to fix this up is we probably need to take away these sharp edges. So we could use some of the sheet metal tools, say the edge flange, really easily. Give that a distance of say 75. And give that a green tick. Maybe we can also apply a hem to these edges just to stop this getting a knee stuck into the bottom of that. So we'll go into our hem tool, just found under sheet metal, and we'll select it there. It's probably a little bit big. We could have a lot of different options. We could have the material going on the inside or on the outside. The sizing is a bit massive. We'll go teardrop. That's looking a lot better. It's in the reverse direction, so we'll flip that. And we'll have the size, let's say 2.5, half the thickness of our sheet metal. Now we don't have to stop there. We could actually apply one to the end of our model as well. So when you don't want your ankles getting scratched on the bottom here. So we'll select that and we'll just reverse that side as well. That follows the same parameters as our first hem on there, this one. Give that a green tick. And we've got a really nice hem that's been produced underneath our sheet metal part. Some other things we can do, as you can see, our sheet metal part is running through our members. So we actually probably need to cut that away. Now, you might have to do this after you've bent this sheet metal part here. You might have to come back and make these cuts. They won't appear in your flat pattern, unfortunately. So on this sketch, we will take the existing geometry, so this, that, and that, and we'll convert those. And just grab the ends to align them up to create some sort of shape that we're going to cut out. Like so. We'll close those off with our sketch entities. We'll just make these vertical, and this one vertical as well. Now I'm going to grab a sketch point and I'm going to place it on the edge of my member here. This is going to control the distance of our cut. That one there. Okay, so we can grab our Smart Dimension tool and go to point to line, and we'll have that at the same thickness of our sheet metal part. Alright. We can also add, say, actually we'll come back and, no we won't. We'll add a 25 mil radius there on this one and that one. And we're just going to do one more at this end. So we'll grab a square, go from this point to that point there, or that edge. Same approach, and just dimension that accordingly, 5mm. This one, let's do another one, and we'll just do it on this edge here. Actually, no, we'll leave that squared off. That looks good. So we'll take that sketch and we're going to cut. And we're going to cut right through both. Okay, give that a green tick. What that has done, it's taken away a nice cut, which is giving us our, looks like we've lost a little bit on our sketch. Looks like we lost the rads there, so I'll just add those back in. 20mm, let's do 20mm, 15mm, that's probably a better size. Okay, we'll do one on this end as well, green tick. Alright, so that's cutting out a really nice shape for us there. Now we can add one last feature here, which is called under the sheet metal, it's called a, it's a break corner. We'll have a radius of say 15mm again that we can apply to these really sharp edges that are around here. Like so. Okay. Now we don't have to select edges, we can select faces as well. This face is not going to enjoy having both corners done, so we'll just leave it like that. We can also apply them down the bottom here. And give that a green tick. And we've got our really nice corner that we can actually not cut ourselves on. So that's the end of creating that component. So we'll exit from that, give it a name, slide will do, and we'll give this a save. And it's going to ask us if we want to save this internally or externally. Let's just do external, okay, and we have our slide. So I hope you've learned a few techniques in creating this slide and weldment. So thank you for watching, and please stay tuned to the rest of our breakout sessions. Thank you.